first started this chapter, I told you that it was kind of separated, where it all didn't just build on itself. But I hope as we've gone through this, you've seen how they really relate to each other. Everything we've done has revolved around drawing a triangle, and we have a radius, and we have the sides, whether we call them A and B, whether we call them B1, B2, whether we call them the real axis and imaginary axis. It all has revolved around this trait stuff. But you just want to kind of go back and remind yourself, hopefully is what the review is going to do for you. Remember that we have vectors, where when we have a vector, we write that as like the components B1, comma B2, the pointed arrows. When you add and subtract and you multiply, you just add and subtract and multiply. What really threw people off with the vectors, it seemed like, was when we wrote it in the IJ form, where you can write this as the same as writing like B1 I plus B2J, where I is a unit vector on the x-axis and J is a unit vector. They're the exact same thing, so if you see this and you don't feel comfortable about it, you can always go backwards and write it as component form to add and subtract or multiply with vectors. We did the magnitude. Remember the magnitude of vector? I think we did just one bar. Do you remember this? One of my books uses 1 bar and one uses 2 bars. 2 bars? 1 bar. Sorry. In my Math 137 book, they do a double bar on each side, and I was confused. But the magnitude is just the length, which is just like the hypotenuse. It's just the square root of like B1 squared plus B2 squared. The same as the R in all of our triangles that we've ever solved. Unit vectors, remember that a unit vector is really nice because it has a length of 1. So there's a formula for that. To find a unit vector, you take the magnitude, so 1 over the magnitude of your vector, and you just multiply that by B1. And you can change it, basically, you can divide the vector divided by its magnitude, and you get a unit vector. We threw the trait part in there with it. Remember that every vector, B1, B2, you could write that in terms of sine and cosine. So then we just say you take its magnitude times the cosine of your angle. That's the first component. And the magnitude times the sine of your vector. Again, very similar to polar coordinates, except for we use A and B instead of the vector B values. No. You're going to get the polar equation in the sine equation. We just did that. No. 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 Why we're reviewing. Why your test isn't for 2 more days. Parametric equations. We had parametric equations we have like this, like x equals t squared plus 1 and y equals t plus 7. We're doing that. 2 equations. This is where when you can make the XY T chart. I have some worksheets that you did over this. I'm going to get back to you so you can see them. This is where you have to make a graph. This is where you have to eliminate the parameter, which means you write it back in terms of just x and y and not t, right? What does parameter mean to get rid of t? So that's where you have to decide which one's easier to solve for. And on this one, y would definitely be easier to solve for. So I would say like y minus 7 equals t, and then I would take that and I would plug it in up here. And so eliminating the parameter, I would get x equals y minus 7 squared plus 1. And that's where we talked about sometimes you have a parabola opening up and down, and when y is squared and x isn't, like that would be a parabola that's opening side to side. And that's where we had to identify some graphs. Sometimes they were circles. That we did that. I have a worksheet that you just turned in at the beginning of last week over that I finally got ready to do that. Then we did polar coordinates. Polar coordinates and vectors. If you remember polar coordinates, vectors are not hard to remember because it's the exact same stuff, except for it's A and B instead of V1 and V2. It's the exact same idea. Remember that that's where we have r equals the square root of a squared plus b squared instead of v1 squared plus v2 squared. It's where we have a equals r cosine of theta, b equals r sine of theta. Did we do a's and b's or did we use x's and y's? I think we did x's and y's. I think this is what we just did. This is why this is all related, and this is why you don't need a note card, because vectors is the same formulas, but it's v1, v2. Polar coordinates are x's and y's, and I was just doing the complex stuff, which is a's and b's, but it's the exact same formula. It's just which letters you're using, which you'll see in the problem that you're doing. Just saying. I feel like sometimes we like vaguely do our homework and then, or maybe just some people don't do their homework and never look back at it. But the idea of the reason I don't collect your homework on the day of the test is so that you're going back and trying to complete it and fill it in as you go, as opposed to saying, I haven't looked at vectors in a month, even though I knew it was going to be on a test, right? Like you should be going back and saying, oh, do I have any homework left I need to be completing? Should I be asking questions on this? Like that's what we should be doing. But we don't, so we just have to review a lot for the next couple days. But we have a final exam coming up that's going to have way more than this, right? So, and usually on the final exam, I let you have some sort of notes. So I think that that's the upside to me not letting you have stuff. But they really are like I just changed it from A's and B's. But it's the exact same thing. When I turn the next slide here, I'm going to write these exact 3 formulas again, except for I'm going to change it to A's and B's. And just to show you here, a little page. Over here, I could say this formula is the exact same as this formula. I could say these 2 things are the exact same thing as these 2 things, right? Like in terms of x and y, that's your r value. Like it's really all the same thing, it's just the different ways that we're talking about it. So yes, it feels like we have 3 separate things, but if you understand the basic of it, of where it comes from, right? In a vector, we talk about we have some vector out here, v1, v2, where we can draw this picture, and this is v1, this is v2, this is my magnitude. In polar coordinates, I have the same exact picture, right? Polar coordinates are where we have those circle graphs, right? So like where we're going to just pretend I'm going to draw this lovely bullseye graph. That's where you have some point out here. But guess what? You can draw that same exact triangle that I drew over here. I can solve the same exact triangle, except for I can call this x, and I can call this y, and I can call this r. That's why it all relates. And on the complex number stuff that we've just been doing, I can draw the same exact picture on the next slide, and I can call this A, and I can call this B, and I can call this R. So if you understand that's where it all comes from, you don't have to feel like you have to memorize a million things, because it all comes from the same idea. It's just relating it back and forth. The one thing that you are going to have to do on polar coordinates is you are going to have to graph, which on that worksheet that you did last week, I'm going to give you some r thetas, right? So that's where we have r theta in polar form. In rectangular form, we have just x and y, right? So that's where I would give you like pi halves 4, and that means you go to pi halves and you go up to the 4th circle. And so that shouldn't be so bad. The other thing that we're going to have to do, which we're going to review on the review, is converting points and converting equations, and that's where this part comes into play. when we do those conversions. Usually we like to try to solve for if we can, but remember sometimes. Okay. This is also where we started graphing these, and that's where I'm going to give you some stuff on the test. All right? So we had some types of graphs here, right? We had Rose curves. I want you to be able to do the Rose curve stuff. I want you to know that, like if I had, like R equals 2 sine of 3 theta, that this number is what tells me my number of petals, right? But if it's odd, that's exactly how many petals there are. So like on this one, there would be 3 petals. But if that's an even number, remember that that's where there's double the petals. So if that was a 4, there would actually be 8 petals. And this number in front is the length of the petal. Right? So how long it is. The limacons, there were 4 limacons. I'm giving you that. All right? So I'm going to write that up there, but I'm giving you those equations. Because remember, that's where it's like A over B, blah, blah, blah. Like, if A over B is less than 1, if A over B is bigger than 2, if it's between 1 and 2, like all the different ones. I don't feel like you need to memorize all of those. So I'll give you those, and I'll look at some other stuff. I really want you to know the Rose curve stuff, so I don't think I'll give you that, but I might give you, maybe the other ones, the lemniscate, the circles. You're not going to have to make a lot of graphs. The one thing I might give you is I might either give you a Rose curve that's graphed and ask you to tell me to write the equation, or I might give you an equation of a Rose curve and ask you to graph it, but just sketch it based on what you know about it, which means it should be a pretty quick graph to make. There's not going to be a lot of graphing on this test. And then the last thing that we did is the complex number stuff, which again, I could draw the same picture here, A plus BI. I could draw a point out here. That's AB, where this is A, this is B, this is R. And you definitely have to go, which I hope if you've been doing your homework the last 3 days, then you know how to go from standard to trig form and trig form to standard form. So remember that A plus BI in trig form is R times cosine theta plus I sine of theta. And again, that comes from that A is our cosine theta and B is our sine of theta. There's some more theorems, or some more formulas you got to know. Multiply and divide, we did that. That's what we went over yesterday. When you multiply the r's, you add the thetas. And you divide the r's and you subtract the thetas. Walt's theorem, where you take it to a power. And the nth roots that we did yesterday. I'm not giving you any of those formulas. That's why when I do this, I don't use the formulas either, right? When I take your test, I don't use the formulas because the one things that I need the formula on is the limacons, which is why I give you the limacons, because I feel like that's kind of confusing. But I feel like if you've been doing your homework, you should be able to do those problems and keep those formulas together. We won't be doing graphing calculator stuff. We did graph on the graphing calculators, but again, your test is very minimal graphing, like at most, I think, like 1 graph, and it's probably a Rose curve. So I'm giving you homework today with the expectation that we'll go over it tomorrow, which means I will check it tomorrow for completion before we go over it, because the idea is you're actually practicing. Excellent. I don't know why I'm having 13. Yeah, so 13 is just no part B. We can still do 13, maybe. Well, no, let's just do it. So the beginning stuff, you're going to see the vector stuff is not so bad. You're going to remember it. And then it just kind of jumps around there, the polar and all of that. And so you can work on this, make your homework for the night, and then we'll go over it. Okay? If you haven't been studying,